Hey guys, so tonight you're going to be learning how to approximate the value of non-perfect square roots. Today in class, you learned about perfect squares and how to get the exact value of perfect square roots. So before we go to non-perfect, let's review what we learned about perfect squares. So perfect squares are numbers that result when an integer is squared. So let's review integers. Integers are any numbers found on a number line. So 5, 7, -5. So again, perfect squares are when you square an integer. So for example, 2 times 2 gives us a perfect square of 4. 5 times 5 gives us a perfect square of 25, and so forth. So we related those perfect squares to actual squares, because when you square the side length of a square, you get an area that happens to be a perfect square. For example, a square with the side lengths of 3 squared, or 3 times 3, gives you that area of 9. So when we take those perfect squares and we apply the square root of it, we actually get that integer value, or a whole number. So the square root of 9 would actually bring us back down to the integer value of 3. So in short, perfect squares are produced when you multiply an integer by themselves. So when you do the opposite of it and take the square root, you're back to that integer value. And you know exactly where that would be on a number line. So determining where a non-perfect square root is on the number line is a little bit trickier. If I look at 2 consecutive perfect squares, 25 and 36, well, a square with the side lengths of 5 times 5, would give me an area of 25. Therefore, I know that the square root of 25 is at the integer value of 5 on a number line, because 5 times itself gives us 25. Same with the square root of 36. I know that 6 times itself gives me 36, so the square root of 36 would be at exactly 6 on the number line. Well, what about all the values in between 25 and 36? The non-perfect squares in between those values must have a value between 5 and 6, but determining that exact value might be a little bit difficult. So, if we can answer this question, what is the side length of a square that has an area of 27? In other words, what times itself gives us 27? Let's take a look. All right, well, we determined that it must be a value between 5 and 6 because 27 is between 25 and 36. All right, so let's investigate a little bit further. If I start squaring decimals between 5 and 6, I can see where square root of 27 would lie. So 5.1 squared gives me a little more than 26, 5.2 squared, a little more than 27. And so I just determined that the square root of 27 has to be somewhere between 5.1 and 5.2, but not exactly either of those decimals, because those decimals squared don't give me exactly 27. So we'll start to see, if we go even further, if I know it's between 5.1 and 5.2, well, let's take it a little bit further. What if I square 2 decimals, or some decimals in between 5.1 and 5.2, like 5 and 1800ths or 5 and 1900ths? Again, I'm not going to get exactly 27. Therefore, the square root of 27, its exact value, or the side length of a square that has an area of 27, is not going to be easily calculated. Therefore, we're just going to approximate it. So again, in short, we know exactly where the square root of 25 would be on a number line, because it has an integer value of 5. 5 times 5 gives us 25. However, we don't know exactly where square root of 27 would be on a number line because no integer squared gives us 27, and we saw that. 5 times 5 gives us 25, 6 times 6 gives us 36, so square root of 27 has to be somewhere in between 5 and 6. So this takes us to our notes. So you added these notes in your notebook, and it says approximating non-perfect squares. So before we get started, I want you to pause this video and I want you to fill in this double number line, labeling where all of your perfect squares would be on a number line. So take a second and do that. All right, let's see if you answered them correctly or filled out your number line correctly. So the square root of 1 would be on 1 because 1 times 1 gives me 1. All right, if I square 2, I get 4. So the square root of 4 is 2. If I square 3, I get 9. The square root of 9 is 3. 4 squared is 16, so the square root of 16 is 4. We already have the square root of 25 as being on 5. All right, 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared, 81. And 10 squared is 100. This double number line will allow you to approximate non-perfect square roots with ease because you can quickly identify between which two perfect squares it would fall, and therefore between which two integer values your square root would fall. So let's practice. So we want to find the approximate value of the square root of 18. There's two easy steps that we already talked about. Number one, you need to answer which two perfect squares is it between. So if I look at the top of my number line, 18 is going to fall between the square root of 16 and the square root of 25. The second step, what is the integer value of each perfect square? The square root of 16 is 4, and the square root of 25 is 5. That tells me that the square root of 18 would be somewhere between 4 and 5. In other words, a square with the area of 18 would have side lengths that are somewhere between 4 and 5. Now we can get a little bit closer. We know that the square root of 18 is closer to the square root of 16, so its value is closer to 4 than 5. And we'll talk about how to get even closer later. Now we want to place the square root of 18 on its approximate location on the number line. Again, we realize you're not going to know the exact location. So somewhere between 4 and 5, but closer to 4, I'm going to put a dot and label it the square root of 18. So those short notes conclude the lesson, but we'll continue to do a couple extra practice problems now. So pause this video and complete the notes if you need to. All right, underneath your notes, write the first example. We are going to find the approximate value of the square root of 98. All right, we need to know the first step is to find out which two perfect squares are on either side of 98. Easy, I know that square root of 100 is very close on the high side. And if I think down, square root of 81 is the perfect square on the low side. Now I need the integer value of each. The square root of 81 is 9. The square root of 100 is 10. Therefore, I now know that the square root of 98, let me change that to a 9, is somewhere between 9 and 10. If I look what the square root of 98 is closest to, it would be 100. So I know that square root of 98 is closer to 10 than it is 9. All right, we're going to do one more practice problem and then we're done. The square root of 78, we want to know its approximate location. Again, we don't know its exact location because no integer times itself gives us 78. All right, I know on the low side would be the square root of 64, and on the high side would be the square root of 81. So these are the square roots of the perfect squares. Now we want the integer value. So the square root of 64 would be the integer value of 8. The square root of 81 would have an integer value of 9. Therefore, the square root of 78 is somewhere between 8 and 9, but it looks to be a little bit closer to 9. Now when you come back to class, we'll talk about how to get even closer than just between two integers. We'll look back at the beginning when we got it down to decimals to the nearest tenth and the nearest hundredth. But there it is, how to find the approximate value of non-perfect square roots. All right, real quick, we want to talk about how to type square roots into our calculator so we can always double check our work. So here's an example of your calculator. It's just two buttons to pop up the empty square root symbol. So you're going to click the second button, which is blue, and then the x squared button down here, a couple buttons down, and you should pop up with an empty square root sign, and you can type your square root into that box and press enter for its approximate or exact value.